am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. In this lecture series video of electron devices and circuits, today's topic is clamper circuits. So in last video we have discussed about the clipper circuits. So the positive clipper and negative clipper, whereas the positive clipper clips the positive part and emits the negative part, where in negative clipper it clips the negative part and emits the positive part. Whereas in clamper is a process of introducing a DC level into a signal, where the positive clampers, the complete half cycle or a full cycle waveform is completely shifted to the positive side, and whereas a negative clamper, a complete waveform is shifted to the negative side, where the diode and capacitor that shifts the input waveform to a different DC level without changing the appearance of the applied waveform. When the diode is forward biased, it will conduct and charge the capacitor. The output voltage across the diode is 0.7 volt. The capacitor is charged to peak input voltage quickly because of small time constant of the circuit. Where in negative half cycle, a diode is reverse bias, the diode become to its states in case voltage output voltage equal to the sum of the input voltage and the voltage across the terminals of the capacitor which have the same polarity with each other. So the waveform is defined in the circuit where the during positive half cycle and during the negative half cycle. uh, During 0 to T1, where the T1 0 to T1 act as a limit, where the input voltage is negative, diode is forward biased and conducts, so V0 is 0 and the capacitor is charged to minus 10 volt with the polarity as shown. During D1 to D2, diode become reverse biased and open circuit, and at T2 when V1 Vi is 10 volt, total voltage change is 20 volt. So during negative half cycle, diode will be forward biased and capacitor will be charged by 5 volt. Applying KVL, so input voltage plus capacitor voltage plus supply voltage, that's equal to act as 0, whereas the total number of voltage calculated is equal to the 5 volt. During positive half cycle, diode will be reverse biased, whereas in negative half cycle, diode is forward biased. In the case of positive half cycle, diode is reverse biased and diode will be open circuit. Where applying KVL, so sum of all these input voltage, capacitor voltage, supply voltage, it's equal to 15 volt. So the gain is larger in the positive half cycle, whereas it is a reverse biased characteristics. The shift will be from positive half cycle to the maximum of the peak voltage of 15 volt, where a voltage multiplier or the circuit which provides a DC output that is a multiple of the peak input AC voltage. Voltage doubler will provide a DC output that is twice the peak input AC voltage, and the voltage tripler which provides a DC output that is 3 times the peak input AC voltage. The basic idea in voltage multiplier circuit is to charge each capacitor to the peak input AC voltage and to arrange the capacitor so that their stored voltage will added voltage doubler. Voltage doubler is during the positive half cycle, diode D1 is forward biased and diode D2 is reverse biased. The charge capacitor C1 to the peak value of input voltage. During the negative half cycle, diode D2 is forward biased and diode D1 is reverse biased. That will charge capacitor C2 to the twice with the peak value of input voltage, because capacitor C1 and input voltage now act as the series aiding voltage sources. During the negative half cycle, diode D2 is turned on, capacitor C2 will be recharged again until voltage across it is again equal to 2 Vp, where the voltage tripler and voltage quadrupler is connected across the diodes, where in voltage tripler three diode is acting, and voltage quadrupler 4 diode is acting, one opposite to each other facing. So the Zener diode is voltage regulated. We already know that it operates in a breakdown region, have a constant voltage regardless the value of the current through the device, that allows Zener diode to be used as a voltage regulator. So the ripple factor is a measure of effectiveness of a rectifier circuit and defined as the ratio of RMS value of AC component to the DC component in the rectifier output. Where photovoltaic diode full wave rectifier, it conducts D1 and D2 is cut off, where in reverse bias D2 will be, which will remains at maximum when V naught is at peak value. Which of the following is not true regarding clamper? For the gain output, find V1 and discharge time. Considering a clamper circuit where capacitance C, load R, the cut-in voltage of diode are unknown, which is the correct statement? So the answers are to reduce the RC value 4.3 volt, the DC level of the signal changes. Thank you.